This is the last year's midterm 3. So I will start from question number 1 and see what we can do. We'll take one by one. So question number 1 is very straightforward question. Just to test you whether you know what is momentum. Well, we all know, right? Momentum is mass multiplied by velocity. But here we have got two objects, A and B. Mass of A is this much and its velocity is this. So not in only in x-axis or y-axis, it's some general direction. It has both x and y component. And B has this much of mass and its velocity is this. Question is, what is the total momentum? Direct question. So if I call the big P for the total momentum, is asking momentum of 1 plus momentum of 2. That will be the total momentum. But then, P1 will be, by the definition, mass of 1, okay, A, we call it A, multiplied by velocity of A, plus mass of B, velocity of B. It's just a matter of substitution, but the only thing is this VA is a vector and VB is also a vector. It's two-dimensional vector. So we cannot just be happy with plus minus. We need to bring in the x component and the y component. So MA is 5 kilogram. So make sure it is all SI units, so you don't have to do any conversion. Yeah, luckily they're all SI unit. So VA is 10. This is how you put the vector. And minus 3. This is this. Then MB is 3 kilogram and VB is negative 10 and 5. That's it. So you just keep doing this because we have to simplify step by step. So this is a scalar and a vector, so it goes in. So each component is multiplied by that scalar. So 5 into 10 is 50, and 5 into negative 3 is minus 15, plus 3 into 10 minus 10 is 30, and 3 into 5 is plus 15. So now you have only the vector addition. So you know how to do vector addition. X component, get them and do the addition. 50 plus negative 30 will be how much? Plus 20. And minus 15 plus 15, 0. So he is asking for the magnitude of the momentum. So you know how to get the magnitude. You take the x component, square it, and the y component, square it, and take the square root of that. That will give you the magnitude of momentum. But you don't have to do this anyway, right? Because one of the components 0 mean the magnitude will be the same as the component that is not 0. So it is 20. So you get this. He's asking only for the magnitude. So we can go to the next. Yeah, sure. It will be recorded. Anyway, you would like to take notes, please do. Let's go to the next. So we have here, if you look at the pattern, there is always a pattern, right? Number 2 question, for if you take last year, it is the same question. You connect the kinetic energy and the momentum. The equation is this: kinetic energy is equal to momentum square. Is also for the all for the magnitudes of the kinetic energy and the magnitude of the momentum. So it's simply a scalar equation. So what he is saying here is the kinetic energy is doubled. What happens to the new momentum? for a given object. That means you cannot change the mass of the object. We only change the kinetic energy by changing the speed. So since we are comparing the P1 with P2, not KE1 with the K2, the question is give P2 some in terms of P1. So the answer happens to be square root of 2, but we need to figure it out. We don't know what the answer is, right? So it is best to write this equation as P as the subject, because we are comparing the P1 and the P2, not KE1 and the K2. So you can write it like this. Momentum is 2m times kinetic energy, right? So with that, I can write for the first instance, the P1 is 2m kinetic energy 1. P2, oh, I forgot something, right? Squared. That's very important, okay? It's not a small mistake. It's a huge mistake. So P2 squared will be 2m KE2. Now I look at this equation, I'm going to substitute for this P2 as much as possible with the 1 terms. Okay, so P2 squared is equal to 2 is a constant. It is not changing when you go from 1 to 2. M is also not changing, the same object. So only the kinetic energy is changing. And we have been told in the question the new kinetic energy is 2 times the old kinetic energy. So here I can write 2 times kinetic energy 1. That's okay, right? So now I'm going to, look at this 2 that is pops up here, and I'm going to take it out and rewrite this. This 2 comes here. Okay, so let me put it in red so you know I'm taking out this particular guy. So that 2 is out. And then you have, if I gather the rest of this, 2m KE1. Now, do you understand what's going on? This is P1 squared. So I can write P2 squared is 2 times P1 squared. Okay, so you can think of it very like without doing any math. You can see that when kinetic energy doubles, the P squared doubles, not P that is being doubled. So the P will be square root of 2 times the initial P1. You can get it here now. This is the relationship between P2 squared and P1 squared. But I want P2 and P1, not P2 squared and P1 squared. So you need to take the square root of this equation, both sides. So this will be P2, and this becomes square root of 2, and the square root of this will be, so P2 is square root of 2 times P1. So that is what he is asking. He is asking the ratio P2 divided by P1, or how much time is P2 in terms of P1. So P1 multiplied by square root 2 is equal to P2. Okay, so the factor is square root of 2. All right, next. Momentum may be expressed in the units of momentum. Of course, you will first, I know what momentum is. You will say momentum is mass into velocity. So according to that, the unit will be mass is in kilogram and velocity in meter per second. So you expect the unit to be kilogram meter per second, but that's not there, right? So then you should remember, I remember a theorem. according to this theorem, P, I know it is delta P. Delta P mean P final minus P initial. So, that means momentum unit and the impulse unit must be the same. And impulse is, by definition, force multiplied by the duration of the force. So, this is, force is Newton and time is second. So, the unit for impulse is Newton second. Then, since they are related directly, that means momentum unit also Newton second. So that means, that is why this is the answer. Now you must be wondering, now we know it is kilogram meter per second, now you are saying Newton second, how come? I can show you they are the same. What is Newton? A kilogram meter per second square, and this is second. Newton second is actually same as kilogram meter per second. So no wonder, that is correct. Now this question you already know the answer, because while we were discussing number 2, and this is the same question more or less. So he's asking what physical impulse has the same dimension as that of momentum. We just discussed that. So that is done. You know it from the impulse momentum theorem. Right. Question, is it question number 5? Yeah. The small car has a head-on collision with a large truck. They hit each other. So they are going to exert force on each other. And then Newton's third law. Although it is now in this chapter, because the impulse coming in and we derive the conservation of momentum based on the impulse momentum theorem and the Newton's third law. Because Newton's third law says when two things put force on each other, those forces are always same magnitude, but in two different objects, object 1, object 2. So, but in the opposite direction. So, the two objects are the small car and the truck. When they hit, they are putting force on each other. So, the force will be same magnitude. So, that's why the answer is A. You can think, okay, what? The truck is very heavy, strong. Doesn't matter. The force will be the same on each other. But why the car is crushed and the truck has not much damage? That's because, let's say the force is 100,000 Newton. 100,000 Newton is too much for the car, it will break. But the 100,000 Newton is not so strong for the truck, it will not break. But the force is the same on both. So, you know the answer to that. So, we go to the next. 1,000 kilogram car is moving due north with a speed of 30 meters per second, makes a 90 degrees turn and moves at a speed of 40 meters per second due east. What is the change in the momentum? Now we are talking about one object, a car, which is at one point in time, it is going north. So this is the car, it is going north and it has a velocity of 30 meters per second in the north direction, and the road is bending at a 90 degrees turn. So now it is going in the east direction. Now the car has a velocity, so let me say V1 here and V2 here, velocity of 40 meters per second. Now it is on the east direction. So we are taking the east as the x-axis, so that's why V1 is 0 and 30. Okay, because now we involve both x and y directions, going to be a vector problem. But the question is very simple question. But here you are tested, whether you understand the directions of vector and two-dimension and so on. He is simply asking to find the change in the momentum. When you say change, it refers to the final minus initial. If I call the final as 2 and the initial as 1, you can call it Fi. It doesn't matter. I just keep switching between them. So it shouldn't confuse you. Final is 2, initial is 1. So you're just asking you to find the P2 minus P1. So it's simply just simple addition, that's it, but vector addition. Okay, so V2 is the same car that is moving in different direction. These are vectors. Now it is not just the sign, we actually have to give the x component and the y component because two-dimensional. So mass is 1000 and V2 is F, right? There it is Vf, but I am calling it V2. Doesn't matter. That should not bother you. And initial is the same as same car, and V1 or V initial is 0 and 30. Now you know this, I mean the vector, right? The x component is the first one, the second one is the y component. All you need to do is to just simplify it further. Okay, stop. Right. So what is this? 1000 into 40 is 40,000. 1000 into 0 is 0. Minus 1000 into 0 is 0. 1000 into 30 is 30,000. Right. Now you know how to add vectors. It's a subtraction here, addition, subtraction, whatever. So 40,000 minus 0 is 40,000. You only collect the x's and do the addition. 0 minus 30,000 is minus 30,000. Yeah, we got the answer. But the question is to find the magnitude of the change in the momentum, right? Now you know how to get the magnitude. Magnitude is, oh, sorry, this is not magnitude. This is in the vector form. So magnitude is the Pythagoras theorem. You take the x component, which is 40,000, square it, and you take the y component, which is negative 30,000, square that too. And you know, this is like the Pythagoras triplet. They call 3, 4, 5. So if it is 3, 4, you know, it is 5, right? 25. So square root of 25 is 5. So instead of 3, you have 30,000. So it will be 50,000. So 50,000 square root, I mean, no, answer is 50,000. Final answer is 250,000 or whatever, 50,000. And yeah, just it will be 50,000. You can check it if you are not sure. You can actually take your calculator and do it, and you will sign 50,000. Yeah. Right. So that answer is there, right? Probably 50K or something, or 50,000. Yeah. It's 50,000. 50,000. Okay, then done. Number 7. A moderate force will break an egg. So, however, if you take an egg and drop it from the same height, one falls on the, say, solid floor, road, okay, road, a solid floor. Other one falls on a grass, okay. And you know, usually, which is dropped on a concrete floor or road, breaks. Which is dropped on a grass usually don't break. Why? The force on them is different. Because maybe the force, or when you drop it on a concrete road, okay, solid floor, the force is greater. But when you drop it on a grass, a cushioned floor, the force is less. Why? Can you explain it? What you learned? What you learned is this. Impulse, the impulse momentum, the impulse is this, right? Equal to change in the momentum. Impulse that is experienced by that egg when it hits the thing and comes to zero velocity, it is proportional to the change in the momentum. So the average force, okay, it's the average force because the forces are not constant here, so we just average force, is equal to change in the momentum divided by the duration of the contact with the egg and the flow. From it, reducing the speed to zero, the time it takes for the egg to come to zero speed. Right, now, in the case of both of them, the delta P is the same, okay, because you drop it from the same height, so when it hits there, its velocity is the same, and they come to zero velocity, both of them. Before they jump off or they stick to that splash, crack, or whatever, it is the same delta P. What is the difference? The time. When you have a cushion like the grass, it will just, it will move further, right? It is not going to break. It will not come to a zero velocity immediately. Because it is grass, it will move a little bit more. That means it will take greater time to come to zero velocity. So the delta T is the one that is different when you drop it on a road or drop it on a grass. When it is on the grass, delta T is maybe 10 times greater than when it is come to zero on a it's zero and moves up. That's a different story. It hits it, and before it moves up, it comes to zero speed. But then by the time the force will be so great, it will crack the egg. So the reason, therefore, you understand why C is the answer. Right. See, there's very little bit of idea only. It is again and again. Now, the first question is simply, what is the momentum definition question. Second question is the relationship between kinetic energy. And the other question, 3, 4, now is all just the impulse momentum theory. So this is also a numerical question now. He is telling this car, it's an impact test to see how strong the body of the car is. So it goes and hit this and stops. So there is a change in the momentum, like the egg being dropped. So it is now all horizontal. And he is telling us the speed before hitting, speed after hitting. So we know the change in the momentum, and the impulse momentum theory. Impulse is equal to change in the momentum, but the definition of impulse is F average into delta T is equal to change in the momentum. So the question is to find the average force. Delta P divided by delta T is a matter of just substitution, and find the answer. So what is this one is M V final minus M V initial divided by delta T. So I can take the M out. It is the same M. How much is that? 1,400. And V final is 0. V initial is 15. And divide by the time it is in contact is 0.15 second only. So you can say this is 15, this is 0.15, that will be 10. 10 into 1,400 will be 140,000. 1,400 into 10 will be 14,000. Did I make something wrong? 1,400, 0.15. Oh no, it is 100, right? Multiply by 100. So it will be 140,000. Anyway, the answer is 140,000. So which is this, right? Because kilo mean times another 1,000, so 140,000. Right, this is a statement question, and you know it or you don't know it. There are two types of collision, right? Any collision can be put into two categories. Either it is elastic collision or a not elastic, but you say inelastic collision. What is the difference between elastic collision and inelastic collision? Kinetic energy. Whether the kinetic energy is conserved or not conserved. If the kinetic energy is conserved, it is elastic collision. If the kinetic energy is not conserved, it is inelastic collision. That's it. There are only two types. So you must be asking, what about this perfectly inelastic? It is inelastic. That's why it is called perfect. But it is a special case of inelastic collision. When the objects come to combine and move together, that is a perfectly inelastic collision. That is inelastic. Any collision, momentum is conserved. It doesn't matter whether it is elastic or inelastic, momentum is conserved. But what distinguishes elastic and inelastic is the kinetic energy. When the kinetic energy is conserved, we call it elastic collision. When it is not conserved, we call it inelastic collision. So you know why that answer is the answer. Okay, I don't need to talk about it, right? All the other statements are completely wrong.
The last one is E, it's perfect.
Yeah. But, there is nothing called perfectly elastic. That's a wrong. You shouldn't be saying that. Collision is either elastic or inelastic. Elastic means perfectly elastic. I mean, there is nothing. I mean, even if a little bit of energy is lost, it is not elastic. It is inelastic. But what happens? People, just say, okay, only little lost, so let me consider it as elastic. They do that. That's why somebody have to say perfectly elastic, says 100% elastic. But actually, something is either elastic or inelastic. Okay, but perfectly inelastic is there. That is a legitimate one. That means when they combine, lock together, that is perfectly inelastic.
If this become elastic and perfect elastic.
Inelastic and perfectly inelastic. There is nothing called perfectly elastic. Elastic is perfectly elastic. Yeah, sometimes they do that. My point here is elastic mean elastic. There is nothing, you cannot say perfectly elastic. But sometimes when they make multiple choice questions, sometimes you see perfectly elastic. But it's when you say elastic collision, mean it is perfectly elastic. There is nothing other than that. Yeah, there is nothing called perfectly elastic. Elastic collision mean elastic collision is 100% elastic. Okay, if to say something is elastic and something is perfectly elastic is just a wrong. Okay, it is wrong. You shouldn't say that. But elastic mean 100% kinetic energy is conserved. But practically, what happens? The measurements are not perfect. So, sometimes there will be little loss of energy, but we'll ignore that and we say it is elastic. Okay, that's right. Never mind. We have spent too much time on that, but let's move on. Right. Now we come to numerical questions. A block of mass m1 is equal to 20 kilogram and speed 2.0 meter per second to the right collides and couples with a block of mass. So you can see the picture, even if you don't read it, you can see very nicely, even the directions are given. So this is what kind of collision? Elastic or inelastic? Inelastic. Why? How do you know it? Is it written in the question? No. Does it say anywhere it is inelastic collision? How do you know that? I mean, join. When they join, no doubt kinetic energy is lost because they combine, the energy become minimum. So you lose some energy, the kinetic energy is lost. So whenever they combine, there will be energy lost. So that means kinetic energy is not conserved. That means it is an inelastic collision. But we have a special name for this. We call it perfectly inelastic collision. Whenever they combine, such kind of collision is called, it is inelastic, yes, but additionally we call it perfectly inelastic collision. That is when they combine. Okay. So it is inelastic collision. Only law we can apply is conservation of momentum. But it is fine, because number of unknowns, the number of things we have to worry about is the masses, m1 and m2, two initial velocities, and only one final velocity, because both of them, we don't need to say v1f and v2f. Both of them moving together. So v1f is equal to v2f is equal to vf. So that's why we just call it vf. There is no subscript 1 or 2 because they both moving with the same velocity. So the number of unknowns also reduced. So suppose, for example, we know the masses, we know the initial velocity. How many unknown now? Only the final velocity. So one equation is good enough for us. We cannot apply the conservation of kinetic energy equation. We can only apply the conservation of momentum equation. So that's what is conservation of momentum? Momentum before, total momentum before is equal to total momentum after. That is what conservation of momentum is. So that's very easy to put for this particular case. Momentum of the first one is m1 v1. Momentum of the second one is m2 v2 equals this side. We don't have to take them separately. It's like just one object. They are both having the same velocity. So the momentum after will be the total mass into the final velocity of that. This is conservation of momentum. Now you substitute, and you can see we know everything except the final velocity. So one equation is enough for us. Okay, then we can solve it. So let's substitute. M1 is 20 and V1 is, okay, now it is a vector equation. That's you have to be keep in your mind. Conservation of momentum is a vector equation. Although it is only one dimensional, everything is moving in right to left in the same line. But however, they are vectors. So you have two directions, a positive direction and a negative direction. So if I take the right side as the positive direction, V1 is positive. So how much is it? 2 plus M2. Where is M2? We don't know M2, right? That is the question. M2 is the unknown. Usually what happens, the unknown is the velocity, right? But in this question, the unknown is M2. So we just write the symbol. We have first, let me write the M1. M1 is how much? 20. So 20. Oh no, this is for M2. I have already finished with the M1. M1 V1. Then M2, which we don't know, multiply by V2F, V2I. What is V2I? 1. But it is going to left. So it will be negative 1 equals, after the collision, M1, we know what is M1, right, which is 20, and M2 we don't know. So we have to write the symbol for it. Multiply by VF. VF is also negative, so 0.20. Look at it. It's just one equation, but we have only one unknown. But the thing is slightly difficult, complicated. Why? That unknown is happening in two places, not in one place. So you need to do a little bit of algebra. But we don't do algebra. We have our calculator. We have our calculator. I'm not testing you for algebra. All I'm worried about whether you know how to use your calculator. Ask the calculator to do all the algebra. I'm not bothered. Let him do everything and give me the answer. So where is my calculator? I need to go to the desktop. Yeah. I'm sorry? Yes, just of course, it's a slightly complicated because the x is coming in two places. It's not a big deal for the calculator. It will do, manage it. So what we do, now I have got the calculator. So let me write this equation, 20 multiplied by 2 plus m2, I'm going to call it x. So alpha, this right parenthesis, multiply by, now you have to be a bit careful here because you are multiplying, right? So use this negative sign and put 1. Of course, because it is 1, you could have just put minus x for the whole thing, but I just want to be complete. Let me do like that. So alpha equal, so that is the equal sign, not the operation. Yeah, minus x. X. Okay. It is okay to put that. I know you know what you are doing. Please go ahead. You don't want to waste time. But I'm just being complete here. So, right. Uh, Equal. Now start the bracket. That is very important. 20 plus alpha x. The x is coming in two places. Right. But the calculator is going to do the algebra. I don't care. Okay, let it do it. It will do it immediately. Multiply by, again, this bracket is important. Okay, the bracket is very important. Otherwise, it will take it as subtraction. You don't mean subtraction. You multiply, right? Multiply by this negative sign and 0.2. You have to remember to close the bracket. Now I know, the equation is good. So, the one thing I have to warn you, please check it again once more, okay? Yeah, yeah. And you made a mistake. So please go through that and check. Even I can do mistake, just although I have done it so many times, still we are human, we we do mistakes, so we have to be careful. Now, once you are confident, you check it again, then shift calc. This is the answer, but actually it is not the answer because I did the same thing for my previous class, so that's why it is there. You really have to press this equal button again, right? So that's right. That is it. So let's go to the next question. Question number 11. 1 kilogram object traveling east at 2 meter per second collides with a 3 kilogram object also traveling to east at 1 meter per second. After the collision, the 3 kilogram object has a velocity of 1.4 meter per second to the east. What is the velocity of the 1 kilogram object after the collision? Okay, so it is, everything is going to the east. It's a one-dimensional question. And do we know, is it elastic or inelastic? We don't know, right? Can I say it is elastic? Why?
Because it's going to the it's one object.
It is. With the final velocity of one of them. Why do you say it is elastic? Elastic means kinetic energy is conserved, right? How do you know the kinetic energy is conserved? No, it's not there. To read it. Does it say anywhere the kinetic energy is conserved?
No.
No. So you cannot tell. I mean, because they don't combine doesn't mean they are elastic. If they combine, we know it is inelastic for sure. If they don't combine, it may be elastic or maybe inelastic. We don't know, right? So, however, elastic or inelastic, we can apply conservation of momentum. So let's apply conservation of momentum. Can I apply conservation of kinetic energy? No. We don't know. If it is elastic, we can apply conservation of kinetic energy. So we're going to have only one equation. But luckily, let me show you. Luckily, we have only one unknown. Because he is giving M1, M2. He is giving V1I and V2I. And he is also giving V2F. So only thing is not given is V1F. So there is only one unknown. So the conservation of momentum equation is enough for us. We don't even have to worry about, we cannot apply that. We don't know whether it for sure it is elastic or inelastic.
Why is it V1 F?
V2F is given. Let me show you. What is this? Let me call it M1. That means this is V1I. Good? Okay. This is M2. If I call it M2, this is V2I, before. After the collision, 3 kilogram, because I told M2 is the 3 kilogram. So 1.4, this will be V2F. It's given. And what is the he is asking for? V1F. Is that clear? You need to read the question, okay? That is important. So we have two masses, two initial velocities, and two final velocities. Altogether, 6 quantities to worry about. Of the 6, 5 of them are given, only one is not given. So one equation is enough for us. So let's write the conservation. What is conservation of momentum? Total momentum before collision is equal to total momentum after collision. Total momentum before will be m1 v1I, that is the first one, and m2 v2I, that is the second one, equals m1 v1f, that is the momentum after collision for the first one, and this is the momentum after collision for the second one. So let's substitute. M1 is 1. Multiply by V1I is, again, this is a vector equation, okay? Sign is important, although it is only one dimension, so right side and left side, east, west. So all of them are east, right? So everything is positive. Because how can you have a collision if they are both all moving in the same direction? It's possible because M2 is going slowly and M1 is coming fast. So it is going to come from behind and hit him. Okay, so that is possible. It can happen. So V1I is how much? 2 plus 2. M2 is 3 and V2I is 1 plus 1 equals M1 is again 1, V1F, which is not known, and plus M2 is 3, and this is also plus 1.4. All you do is just solve it. You don't even need a calculator for this, right? No, you don't even need a solving mode. No, just what is this? 2 plus 3 is 5. And V1F, 3 into 1.4, you can even do your mind. 3 into 4 is 12, 3 into 1 is 3, 3 plus 1 is 4 plus. Okay, so this gives me, I'm not telling to do it like that. You can, of course, use the calculator, but you know, V1F 5 minus 4.2 equal to 0.8. Is it positive or negative answer? Positive answer. That means the direction is east. Okay, so that's
I have a small question.
oh, the same question. Come on, in everything, same question.
What makes you tell it's not elastic?
Yeah, let me go back. Okay. Elastic collision means kinetic energy is conserved. Total kinetic energy before is equal to total kinetic energy after. Only if I do the calculation, we can find out, unless either the question, the guy who give me the question has to tell me, okay, this is elastic collision. He didn't tell anything. You know, usually what happened with the student, they think like that. When they combine, inelastic. When they bounce, elastic. That's not true.
Actually, I used the elastic formula and it's the same answer.
No, this is not, this formula we can use for any collision. It's a conservation of momentum. It is applied to elastic collision, also inelastic collision. Yeah, that is conservation of momentum. You can apply conservation of momentum to any collision. Not because it is elastic. Whether it is elastic or inelastic, conservation of momentum is applied. The second one, the kinetic energy conservation, you cannot apply. Right? I am also using the same thing. I am using the conservation of momentum. And you can apply conservation of momentum to any collision. In any collision, you know, if you take right before and right after, momentum is conserved. That's why we took that. Right, next. One kilogram block moving to the right at 2 meters per second collides head on. When the collision is head on, what it means is one dimensional. Everything is in the same line. Right side, left side, or up, down, in the same line, in x-axis or only in the y-axis and so on. So it's a one-dimensional collision. And also he is saying it is elastic. Here the question itself is telling us it is a elastic collision. So we have to accept whatever he is telling because he is the one giving the question. Yeah, you can use both conservation of momentum as well as conservation of kinetic energy. No, it is not it's both independent equation. Wait, I'll tell you. Now, how many quantities we have? 6, right? 2 masses, 2 initial velocities, 2 final velocities, 6 of them. If you read this question, he is giving masses, he is giving the initial velocity, that's all. So you have 2 unknowns, final velocity of the 1 and final velocity of the 2. So if I have only conservation of momentum, in that equation we will have 2 unknowns. Can I solve it?
Yes.
Okay, let me give you an equation. X plus y equal to 2. Solve for x and y. You said yes before. Now you are saying no. Right? 2 unknowns, only 1 equation. How can you solve for x and y? There are many solutions. One maybe if you take x is equal to 3, y will be minus 2, minus 1. Right? So there are many solutions. 0, 2, 1, 1. So you don't have a solution. So that is why when you have 2 unknowns, we need 2 equations. So that's why when we were learning chapter 2, the kinematics, I told you there are only 2 independent equations. So the maximum you can have is 2 unknowns. If the number of unknowns are more than 2, we cannot solve it. So here, luckily, because the elastic collision, I can have 2 independent equations. One is the conservation of momentum, so it will be m1 v1i plus m2 v2i is equal to m1 v1f plus m2 v2f. So this is the equation number 1 in your formula sheet. The kinetic energy equation will be half m1 v1i squared plus, but we don't like that equation. Why? Because it has got square terms, right? So when I try to solve them together as a set of equation, it is going to give us trouble. Because linear equation is fine when they don't have to the power 2. If everything is to the power 1, this is good. So what we do a trick. We use this equation and the kinetic energy conservation equation and come up with another equation, which is a linear equation, no square term, but vector. This is the equation number 3 in your formula sheet. So this is equivalent to applying the conservation of kinetic energy. Yeah, it's actually the combination of both, but the conservation of momentum is already there in number 1. So we will say number 3 has the conservation of kinetic energy. So why we prefer this number 3? Because it doesn't have a square term. Also, it is much easy because they don't have even masses. Right? It can be different masses, whatever, it doesn't matter. We can just apply that. Right. Now, what we have here is whether you know how to apply, that's it. You are not supposed to calculate it, okay? So whether this one is coming from equation number 1, this one is coming from equation number 3. Conservation of momentum, conservation of kinetic energy. So let's do the first one, equation number 1. Somebody help me. M1 is, I'm not going to look at it, so somebody has to tell me. What is M1? 1. And V1I?
2.
Plus or minus? Plus. Okay, then plus. M2 is? 2. And V1, V2I is? Minus 2. You know what it is, why it is minus, right? No issues. So this is very important. If you make a mistake, because of vector equation, okay? I mean, you cannot say, oh, I made a small mistake. It's not a small mistake. It is the mistake. Okay? You cannot say, I made a small mistake. I mean, you got it all wrong. You know, you're done. I mean, you didn't understand. That's what it means. Equals. on the right hand side, again 1 multiplied by V1F. We don't know V1F, right? So we have to just put the symbol for that. Plus 2 V2F. Let me simplify. So 2 minus 4, which is minus 2. Right. Leave it aside. Okay. Now you got this. Is that the only one giving this? No, there are maybe others. Anyway, we got the first one. Now let's go to the second one. This number 3. So again, somebody help me. V1I is 2 plus 2 minus V2I is minus 2 equals this. These are all known, not known, right? So you have to leave it like that. Minus goes in, it will be minus V1F, minus minus will be plus V2F. So this is my other equation. So when you further simplify, 2 minus minus 2 will be plus 4. Okay, done. So you know A is the correct answer. Can you solve this? Yes, but I'm not telling you to solve. I just want to know whether you do the physics part. Solving, you can use the calculator and the equation mode phye1, yeah, A1, B1, C. You want me to solve this?
No, just because the test and the calculation.
Yeah, ABC, the matrix. Yeah, you know which is A, which is A1, B1, C1. Yeah, let's not bother about it. Okay, so, but in the special mode phi and 1, you know that, right? It showed you. Yeah, mode phi, you get then the first one, mode phi and 1. And
ABC.
A1, B1, C1, A2, B2, C2. Okay. Number 13. See, it is the same concept. We have so many questions. It is conservation of momentum, conservation of momentum. So there is a collision. But what is complication here? Two-dimensional. Other than that, it is the same equation. Total momentum before equal to total momentum after. What is the question? There are two vehicles coming like that. They collide and they lock together, become one. Now, what kind of collision is this? Now you should be given definite answer. Is it elastic or inelastic?
Elastic.
Elastic or inelastic?
Elastic.
Perfectly. Whenever they combine, they don't have to tell you. When they glue together, lock together, whatever, entangle or whatever, we know for sure it is inelastic. It's not just inelastic, it is perfectly inelastic. So the question will not tell you. They will say they lock together. So can I apply conservation of kinetic energy? No. We can apply conservation of kinetic energy only when it is elastic. Is it going to be a problem for us? No, I don't think so. Otherwise, they will not tell you, because we will see that we have only one unknown. So one equation is enough, which is a conservation. Yes, M1 V1I plus M2 V2I is equal to, because now here they both have the same velocity. So you can say M1 plus M2, both of them is just one velocity. It is the exact same equation, right? But only thing is now V1I, V2I, they are all going to be vectors, because both directions are involved. You cannot just say plus direction and the negative direction only. We need to bring the two components. That's the only difference. But you know how to deal with vectors. That should not worry you that much. So let's, this is M1, so 1000. And you do this. You know how to give the vector in an angle bracket. X component is, you're being helped a lot. 20, no, yeah, this one, M1, 20 and 0. And M2 is also 1000, same mass, okay. They both cars have the same mass. Multiply by 0 and 20. equal to m1 plus m2 will be how much? 2000. And this is the unknown, right? Let me just give it as just one unknown. Okay, we want the whole thing as one. It's x and y component at the end. Right. So let's simplify this. So you go slowly, do this multiplication of the vector first. So it will be 1000 into 20 will be 20,000. And this 0.
But before we do that, we need to make sure about the negative or positive.
Oh, yeah. Yeah, but it is not only one direction, right? It is a vector. Yeah, so east mean plus 20, right? I already, because, yeah, suppose it is west, you should write negative 20. So because we were in positive direction, I didn't stress that, but good that you reminded me. So, but we did it correct, right? M1 is east mean plus 20, x component is positive, y component is 0 anyway. There is no y component. And for this guy, M2, x component is 0 and y component is positive 20. Okay, so we took care of that. And here after, we don't know this. We really don't know. So there is nothing to talk about here. I'm just putting the symbol. We don't know which direction it is. So I'm just calling it VF. That is what we are going to find out. Okay, all right. So 20,000 plus 1000 into 0 is 0. 1000 into 20 will be again 20,000 equal to 2000 VF. Let me move a little down. Now you can add this. That shouldn't bother you. You know how to add vectors. Only the x's, it will be 20,000 plus 0 will be 20,000. Only the y, 0 plus 20,000 will be 20,000 again. Equal to 2000 VF. So this give me VF equal to, this 2000 come here and come here, right? So 20,000 divided by 2000 will be 10. 20,000 divided by 2000 will be again 10. So it is done. Okay, this he really wants as a vector. He didn't say magnitude, did he? No. He just wanted a vector, so 10, 10. Suppose he asked you, okay, I don't want as a vector, give me the magnitude. Yeah, square root of the sum of the squares, okay, x component and the y component. All right, and I think I can skip this because we did this. I want to go to this question, okay, 21. So we have a car which is going in a circular path, at least momentarily. When it is going like that, it is going in a circular path. Of course, it's a big radius. It's given somewhere 20 meters. Okay. Anyway, it's a circle. So then when something going in a circular path, you are going to apply the Newton's second law. But what happens, the acceleration is the centripetal acceleration, and this is the centripetal force. Centripetal force means it stands for all the forces in the direction of the centripetal acceleration, right? So we have to have the free body diagram, that means show the forces already there. Okay. Well, of course, there will be friction between the road. These are tangential, perpendicular to the acceleration direction, right? So they will not contribute in the acceleration direction. So we only have to worry about the forces that can contribute to the centripetal force. So this one, I want to take the positive direction in the direction of the acceleration. What is the direction of the acceleration? It will be down, right, to the center of the circle. Center of the X somewhere here, down. So from the car, the direction of the acceleration will be down. So down, take the acceleration direction as your positive direction. That will make things easy, okay, without confusing. So in that sense, mg is positive and n is negative. So this is the total centripetal force is mg minus n equals mass of the car, and you learned that centripetal acceleration can be given in terms of its speed. Speed squared divided by the radius of the circle. That's it, we are done. The rest is just substitute and find the answer. The unknown is n. You can do simple algebra. It's not a very difficult one. So n is equal to mg minus mv squared over r. I just quickly did in my mind, okay, so that's, and you just substitute and find the answer. No big deal, all right. I need to tell you this, okay. Let's say it is like this. So the circle is not like this, but like this, say for example. So it's a pit and the car goes like that. Again, it is circular path, right? Now, suppose you are asked to apply the Newton's second law, how would it look? Now, what is the direction of acceleration? Up. Direction of acceleration is up, not we don't say positive, negative. Up, down, okay? Direction of acceleration is up. So with that, n is positive, mg is negative. So for this particular question, if you ask to apply the Newton's second law, this will be plus n minus mg is equal to m. This is in that direction, so positive v squared over r. See, it is not the same as this, right? So you have to be careful, okay? Right? Of course, you are not going to memorize this equation. You should be able to, these are not in the formula sheet, okay? These are not in the formula sheet, but it's just what is in the formula sheet is that Newton's second law for circular motion. Oops. 29? I'm sorry, I didn't hear. Yeah. Suppose it is like that, you know how to write this Newton's second law correctly, right? The direction and all.
40.7 times 1,000.
Anyway, whatever it is, okay. I mean, I don't want to go further than that. You make your own thing, okay, right? It is a different equation. That's all. That equation mg minus n is equal to mv squared. This is minus mg is equal to mv squared. Right. So okay, this one. I want to go through the concept again. I know I told you about this in the class, but let me repeat. So, suppose there is a road which is level. Say the road is like that. Okay, my palm is making the road. I am paving the road. So there is a road like that, a level road. But I need to take a turn. So the road go like that. So there's a curve. So the car is coming. Let me say this is the car. So the car will be going road. It will be going like this. It will be describing a circle. Okay. So I'm looking from behind. So this is the car. But I don't want to come to the bank road. Let's say it's a level road. And the car is here. Say it's a level road. So you have a road like that. It is a flat road, not banked. So the car is going to take a turn. Right. So what are the forces? Normal force and gravitational force. And what is the direction of the centripetal acceleration? It will be to the center. Say this is my center of the circle. It will be to the left, right? Okay, got it. Right. Can n provide the centripetal force? centripetal acceleration direction is horizontal and the normal force is vertical. What is the angle? 90 degrees. Cosine 90 is 0. The vertical forces cannot help. What about mg? That is also 90 degrees. It's down vertical, that is up vertical. They cannot help to do this circular motion. M cannot help, mg cannot help, simply because they don't have any component in the horizontal direction. So, but cars do take turn, right? No, don't you drive a car and you take a circular path? It's possible. How? N force cannot do it. Mg force, what is the force that is supplying the friction? Between the tires of the car and the road, there is friction force, the static friction actually. So the only thing we can do this curve because there is friction between the tires and the road that can supply. But when you go in a highways, cars has to go like 200 kilometers high speed. So centripetal force is m v squared over r. If this v is big, the centripetal force is becoming big. You need that much of centripetal force to make it go take that circle with that speed. Friction force, not that big. It will have a limit, a maximum value for the static friction force. So with the speed of like 200, 300 kilometers per hour, the friction force is not enough. That's why if you do very fast with your car and take a turn in a flat road, especially flat road, you will skid. You know the word skid. It fly off the tangent to that circle. So they know about it. So they do a trick. What is the trick? They bank the road. So the road, without being flat, they will raise the thing by certain angle theta. You know what happens now? Now, before the direction of the normal force is vertical. Now it is not vertical. It makes an angle of theta degree. If this angle, the banking angle is theta, the normal force will also make an angle of theta with the vertical. So that can be proved, but anyway, we just remember that. So if the banking angle is theta, the normal force will not be in the vertical direction. It will make an angle of theta with the vertical direction. Now, there is a component. It is not 90 degrees anymore. The component of normal force along the acceleration direction is n sine theta. And sine theta. Now you must be wondering, how come horizontal component is sine and the vertical component is usually y component is sine, x component is cosine, right? Why? Because the angle, when the angle is with the x-axis, it is cosine theta and along the x-axis and sine theta along the y-axis. But now what happened? Theta is the angle with the y-axis. So y component is cosine theta, x component is sine theta. So that should not bother you now. Okay, right. So anyway, so now we have everything we need. So even friction is small. So what the n is providing us is enough. We don't even have to worry about the friction. So even without the friction, the normal force, its component along the acceleration direction can provide the enough centripetal force. So we apply the Newton's second law. The centripetal force, let's say it's coming only from we ignore the friction. So the only force is the force from the normal force, which is n sine theta in the acceleration direction. Mass multiplied by the centripetal acceleration is v squared over r. Okay, again, it is not a numerical question, just making sure you understand how to get that. All right. So, for example, If you apply the Newton's second law in the y direction, what do you get? Yeah, this is n cosine theta, and we ignore, there's no friction, that is the only thing, minus mg. Mg is there, right? It's in the negative direction. Equals mass multiplied by acceleration in the y direction. Now we are going to assume the car, although it is in a banked road, it is not going up and down. It is only describing a horizontal circle. So there is no vertical motion for the car, right? If there is no vertical motion for the car, acceleration vertically 0. So the equation in the y direction is this, okay, right? So what about n now? If someone asks you to find n is equal to mg divided by cosine theta.